Okay, welcome everybody. My name is Brian McLogan, and what I want to do is go with you, walk you through some homework that I had for my students here in functions of complex zeros of polynomials. So what we're going to do, a couple of the problems we're going to be looking at here in this live stream is covering finding the zeros and multiplicity of a polynomial as well as writing the linear factorization. Then we're also going to get into how to find all of the zeros when actually in this case we're given we're given a zero or zeros. And then we'll look into writing the equation of a polynomial when given zeros with their, with multiplicity. I guess there's no multiplicity in this one. So just given the zeros as complex zeros. And then what I'll do is then we'll kind of work into some multiple choice questions for you to kind of practice on. So as I've done in my previous live streams here, I'm going to kind of work through some different examples. If you have questions, feel free to add them into the chat. See you guys, there are a couple of you coming in. Hey, Nathan. Hey, Mignek, sir. Sorry about that. I'm not sure how to pronounce exactly the name, but, welcome guys. If you guys have any questions or anything on the live stream, what I'll do is I'll work through these first 3 questions, and then what I'll do is I'll kind of take a break, check back in with the chat, and then after the quiz, after I'm completed with, the homework, if I have any other questions or in general or on math, then I will be happy to answer them for you as long as I have time. So, hey, Mimi. Hey, Haley. Glad you guys could join here. So let's go ahead and get started so I can get this through, and then I will join back with you guys here at my mid-break. So, all right. Complex zeros of polynomials. So what we're looking in here is finding the zeros and multiplicity of the following polynomials by writing the linear factorizations. So basically what we want to do in this case is find the zeros, and at least start. So by finding the zeros, what we're going to be looking for here is we're going to be looking for the values of x that make this equation true. X to the fourth minus 1 is equal to 0. And basically what we're doing is we're looking for some factoring techniques. Now, whenever I see a polynomial that has 2 terms, I'm usually going to be looking into factoring using the difference of 2 squares. And you want to be careful by using the square root method here because you're just going to be taking the 4th root, and that's not going to be the whole story. That will give you the real zeros, but it's not going to give you what we're talking about today, which is the complex zeros. So that's why it's really important to make sure we can factor this using difference of 2 squares, which would be x squared plus 1 and x squared minus 1. Now, for this first example, I will use zero product property to write our linear factorization, but then I'll start relating how I want us to kind of get used to going from difference of 2 squares, not only across rational numbers, but across irrational as well as complex numbers. But in this case, let's just say, hey, we have a product equal to 0. Again, if you want to check my work, multiply these and you'll get x to the 4th minus 1. So now for x squared plus 1 equals 0 and x squared minus 1 equals 0. And therefore, when I go and solve, I get x squared is equal to -1 and x squared is equal to +1. Now, to undo the squaring, I need to obviously take the square root, right? So we're going to square root both sides. And for the positive one, we're good, right? Just remember when we introduce the square root, we have to include plus or minus 1. But here, we're going to have to use the complex number system because we don't have a real number where you can take the square root of a -1. So therefore, in the complex number system, we use the imaginary unit I to represent the square root of -1. So therefore, these are my zeros. And so I'll just write these as we'll say zeros. And I can say plus or minus 1 and plus or minus I. And then if I was going to write the linear factorization, basically the linear factorization is taking each one of these zeros and setting it equal to 0. So if you wrote these out, you can basically write these as the linear factorization. We can write this as x minus I times x plus I times x plus 1 times x minus 1. And again, if you were to use the zero product property to solve these, if you were to set this equal to 0 and solve, you would get plus or minus I and plus or minus 1. So that's exactly where you can find the zeros and then take the zeros and write them as factors. That's one method. The next method here, or the next problem, we'll work in here. We're going to, again, set this equal to 0. So we want to find the values of x that make this equation true. The first thing I notice here is they all are divisible by 2. So I'm going to factor out a 2. So I factor out a 2, and I'm left with x to the 4th plus x squared minus 3. Okay, and typically now you could go ahead and divide out this 2 if you wanted to from the onset, because it's not going to be affecting the value of the zeros. Okay, I'm just going to leave it there for right now, and we'll divide it out. I'll just leave it there. It's not going to affect anything. But again, you could, well, I'll just write out. You could divide out that 2, right? For instance, now let's go and factor this. Now, again, when I'm factoring to higher powers, what I like to do is just think of this as like a quadratic. Forget about for a second that it's to the 4th power. Just think of this as like a quadratic. If this was x squared and this was x, then how would I go ahead and factor this? Well, I'd ask myself, what two numbers multiply to give me -3 and add to give you a +1? And actually, this is non-factorable, so I did make a mistake in my example. I was trying to like fix this. That was not right. This was supposed to be a 4, because that should be a 2. So sorry about that. I was wondering, I was like, I looked at the problem just beforehand, just enough time, and I was like, crap. So therefore, if I factor that out, then that will be left with a 2. So there we go. These are all supposed to be factorable. So obviously, we'll talk about when they're not factorable in another lesson. So here, when I factor this out, I'm asking myself, what two numbers multiply to give me -3? And then therefore are going to add to give you a +2. But then again, yes, that would work. So therefore, that's going to be x plus 3 times x minus 1. There you go. But again, this times this gives you x squared, right? So we need to raise the power of the factors. So therefore, it's going to multiply to give us x to the 4th. Okay? Now, as you can kind of see here, I have x squared minus 1 again. Right? So I don't need to solve this here. I can kind of skip already to my linear factorization. So therefore, this is going to be 0 equals 2. Now I'm just going to write this factored out. X minus 1 times x plus 1. And the point that I want trying to get to, guys, is if you have x squared plus 3, could we set x squared plus 3 equal to 0 and then go ahead and solve? Yes, you could. But what you'll notice is you're going to be subtracting the 3 and then taking the square root of it. So you're going to be taking the square root of a negative number, which is going to produce I, and you're going to be taking the square root of 3, which is irrational. So rather than solving this and getting my plus or minus and then plugging them back in, I recognize this relationship is going to be x minus I square root of 3 times x plus I square root of 3. And again, guys, if you're looking for a little bit more of introductory or slower pace in this, again, this is just a homework example. So we've already kind of discussed this in my classes. So that's why I'm kind of, showing them a little bit of skipping some steps here. Then obviously now, like you could go from the zeros, or we can just write the zeros here as plus or minus, not I, plus or minus 1. And plus or minus I square root of 3. And you could write this I after the square root of 3, but we don't want it to be confused under this radicand. So sometimes we either close the radicand, or it's just easier, it's more preferred to write the I in front. All right, so the next example here, we can have 4 terms. So this is going to be a little bit different technique, factoring technique than with trinomials, but the same idea. We're trying to find the zeros, so we're trying to set it equal to 0. For this technique, what we're going to do is group the first 2 terms, group the last 2 terms, and now what we're going to do is factor out the GCF of each of those groupings. So the common factor here of 4x to the 4th and 4x cubed is going to be, let's use a different color, let's use red. It's going to be 4x cubed, and when I factor out a 4x cubed, I'm just going to be left with a x plus 1. And then over here, again, you want to factor out, so you're still going to get this x plus 1. And here, I can factor out a 3x. So by factoring out a 3x, again, I am going to be left with a x plus 1. And now, hopefully what you can see here is these 2 expressions have a green x plus 1 in common. So we can factor that x plus 1 out. Okay, and that's going to be, we're going to be left with our red here, which is a 4x cubed plus 3x. Now, I didn't do this at the beginning, and this is usually best practices here. You can see that they all share an x, so you could have factored out an x from the onset. That would have been typically preferred, but we can go ahead and factor out that x here, and so let's go and factor that out. So if we could leave this as a x plus 1, and then so I factored the x from this, so therefore I'm left with a 4x squared plus 3. All right, now this might not be as easy for many students to visualize like what this is going to look like, when I solve this. So in this case, to write the linear factorization of this, I'm going to set this equal to 0 and solve. So some of these, like for here, I want you to kind of identify these patterns so you can, factor them by difference of two squares. But here, 4x squared plus 3 equals 0 might not be that simple, all right? So what we're going to do here is just subtract a 3. Then I have a 4x squared equals negative 3. Divide by 4, divide by 4. X squared is equal to a negative 3 over 4. And then I need to take the square root. Take the square root. Again, you're taking the square root of a negative number. Now again, we can break this square root into the square root of the numerator and the denominator. So therefore, I'm going to be left with x equals plus or minus I square root of 3 over 2. And sometimes we'll write this I in front, not just in the denominator. So let's go and write the linear factorization out with that. So the linear factorization here is now going to be x times x plus 1 times x plus 1/2 I square root of 3 and x minus 1/2 I square root of 3. Looks kind of crazy. That's the linear factorization, so that's going to be our function h of x. Oops. And then my zeros in this case are just going to be 0, negative 1, and plus or minus, I'll just write it as I square root of 3 over 2. So you could write it as I square root of 3 over 2, or just put the 2 in front as a multiplication right as there. All right, working on the next one. It says find all of the zeros. So we're given a 0, and one thing you can do is, immediately once you're given this 0x, you know that x equals negative 3i exists. And one thing that I used to teach for a lot of students was to, take this negative 3i, or take the 0, one of the zeros, 3i, and then do synthetic division. Because when you're given a 0, it's usually synthetic division is pretty decent to do. And you can do it this way. There's really nothing wrong with doing it. But what I've found is when students are doing synthetic division with their complex numbers, they just make their mistakes with the, operations of complex numbers. So I stopped really teaching it, and I really just kind of focused on really our understanding of what it means to have a 0. And the understanding is if you have a 0, then you have a factor, right? And remember, factors are what evenly divide into a polynomial. So if these are my zeros, then that means I have these two factors, x minus 3i and x plus 3i. Right? So just like 12 has factors 3 times 3 and 4, right? Because 3 times 4 equals 12. But you see here, this times this does not give you f of x, right? This times this is going to give you x squared something. So that's like saying 2 and 3 are both factors of 12, but 2 times 3 does not give you 12. So what we can understand here is this times something else is going to equal f of x. And that something else is also a factor where we can find the remaining zeros from. So what we want to do is multiply these, okay, and therefore then we can divide that into f of x. And since it's going to be a quadratic, we're going to have to use long division. If you want to do the synthetic division with 2 zeros, go ahead and do it. Just make sure that you divide with 3i and then take the quotient and then use that with negative 3i, which I have multiple videos showing with that as well. So so we got to multiply this. So again, notice that this is a difference of two squares. That's why having complex conjugates is awesome. We can basically just multiply these. X times x is going to be x squared. Negative 3i times positive 3i is a negative 9i squared. Well, I squared is negative 1, so negative 1 times negative 9 is going to be a positive 9. All right, so therefore then we take our polar dividend with x to the 4th plus 4 x cubed plus 13x squared plus 36x plus 36. Okay, so again, when doing long division, you're trying to determine x squared divides into x squared how many times? And again, if you kind of get confused, just write it over here. X to the fourth divided by x squared. Use the rules of exponents. 4 minus 2, right, is x squared. Then just make sure you multiply this x squared times both terms. So therefore, we're going to get x to the fourth plus 9x squared. Okay. Then we're going to want to make sure we subtract our rows. I always like to use parentheses because this is where I see students make mistakes. X squared minus x squared is just going to be 0, x to the fourth. Then I can bring down this 4x cubed. Okay. X squared now divides into 4x cubed. How many times? Well, again, just rewrite over here. 4x cubed divided by x squared. Well, that's going to be 4x times. So, all right, plus 4x. 4x times x, 4x times x squared is going to be, oh, I forgot to bring the rest of these down. Sorry about that. I automatically started going to the next step. Let's bring everything down. 13x squared minus 9x squared is going to be a positive 4x squared. And then these I have nothing to subtract from, so I'm just going to bring them all down. Okay, so now x squared goes into 4x cubed, 4x times x squared is going to be 4x cubed, and 4x times 9 is going to be 36x. Now, again, it's really important to make sure that you, whenever you're multiplying this back through, you should always get that first term to be the same because you just divided it to get that term, and you obviously want to subtract to 0. So now let's go ahead and subtract the rows again. And here again, we're going to get 0, which is good. We can basically subtract this from 0, so that's 4x squared. And that goes to 0, and then we're left with a 36. Okay, so now we do it one last time. X squared divides into 4x squared. So 4x squared divided by x squared, you can see as positive 4 times. 4 times x squared is a 4x squared. And 4 times 9 is a positive 36. So when we subtract the rows, you guys can see that we get 0. So perfect, right? We know it's a factor and it's going to divide into it. And the important thing here is this quotient is also a factor, right? This quotient is x squared plus 4x plus 4. It multiplies times the other two factors to give you your f of x. And remember, what we can do for all our factors, to find the zeros, you set each factor equal to 0. So all I got to do to find my remaining zeros is take this factor, x squared plus 4x plus 4, and set it equal to 0. Well, I can factor this to x plus 2 squared equals 0, and therefore x equals negative 2 with a multiplicity equal to 2. So there's my 0. That's one of my zeros. And then my other two are plus or minus 3i. Okay? Because that was given to us, right? They were given 3i, and then we know that negative 3i must exist. Working into the next one. So we have f of x equals 2x to the fourth minus x cubed minus x squared plus x minus 9. And we're given two rational zeros. Now, here's where I'd really like to use synthetic division. And since we already did a long division problem, this one kind of works out perfect. So remember, with synthetic division, you're just going to take the 0, and you're kind of going to do an inverted long division. Now you're going to take the coefficients of each of your polynomials. So here I'm going to have 2, negative 1, negative 1, 1, and negative 1. And just remember, if you are missing a term, like if you didn't have an x cubed, you make sure you use a place value of 0 for that. All right, so for synthetic division, you always bring down the first one, which is a freebie, which is 2. You always multiply on the diagonal, so 2 times 1 is 2, and then you add on the vertical. So let me just put those little points there. So you multiply on the diagonal, and then add on the vertical. Now, again, guys, synthetic division is just really a trick, right? It's just a way for us to help do division a little bit easier and quicker. You can still do this problem with long division, and what I'd recommend doing is just like we did here, multiply, write our zeros as factors, multiply them, and then do long division into this polynomial. It would work the same, you'd get the exact same answer. But anyways, let's just finish this up because we started with long division. So negative 1 plus 2 is 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1 is 0. 1 plus 0 is 1. 1 times 1 is 1. And that is 0. Now, I could go ahead and write this as my polynomial. Like that's my remainder, my constant, coefficient of my linear, coefficient of my quadratic, and then coefficient of my cubic. Because that's what, since we took the coefficients to do synthetic division, the quotient is in coefficients. So we would have 2x cubed plus x squared plus 1. But the problem is, even though that is a factor, I can't set that equal to 0 and solve like I did over here, right? I don't have a solving technique here for this one. So that is not going to be a good method. I'm going to have to continue working on this. So what I'm going to do is I'm going to break this down further. It's like taking 12 divided by 2 and giving you 6, and then dividing by 2 again to get down to 3. Like we're trying to break down the factors. So I'm going to take this factor, and I'm going to divide it by the other 0. So what that means is I'm going to take now -1, and I'm going to not use the original coefficients, but I'm going to use the coefficients of the factor, which are 2, 1, 0, and 1. So now let's do the whole process again. 2, 1, 0, 1. Okay. Again, this is a remainder, so I don't need it. So I bring down the 2. 2 times -1 is -2. 1 plus -2 is going to be a -1. 1 times -1 is going to be a positive 1. 0 plus 1 is 1. 1 times -1 is -1. Okay, so now let's go ahead and write this out. So again, actually, I don't know why I stopped that. That's 0. That's the constant. Coefficient linear, coefficient of quadratic, coefficient of cubic. So what that means is this answer is remainder constant linear quadratic. So therefore, I have 2x squared minus x plus 1. Okay, now again, I'm going to have to set this equal to 0, and I want to go ahead and solve. But immediately, once I try to factor this, I try to see, how can I break this down into two binomials that are going to multiply to here? And what I see is this is non-factorable. So when something's non-factorable, what I'm going to need to do now is use the lovely quadratic formula. Whoa, slow down. So quadratic formula, x equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. Okay, so we got to be prepared for this unit with the quadratic formula. So let's go ahead and plug this in. So x is going to be equal to, let's see, 1 plus or minus the square root of -1 squared minus 4 times 2 times c, which is 1. And that's all over 2 times 2. All right, so let's do some math here. So 1 plus or minus the square root. So we have 1 squared, and then we're going to be subtracting that from 4 times 2, which is going to be 8. So 1 minus 8 is going to be -7, and that's going to be divided by 4. Okay, now obviously there's nothing really we can do with this 7. So rather than, redo that line. So there's nothing really we can simplify here with this, but we can rewrite this with an imaginary unit. So therefore I can rewrite this as 1 plus or minus I square root of 7 over 4. And another way that you might see this is with this 4 distributed. So it'd be like written as 1/4 plus or minus 1/4 I square root of 7. So these are all equivalent forms, okay? And on a multiple choice test, you just have to make sure you understand that these are the same. Now, as far as writing the zeros, then either one of these forms is going to work. So we just have 1/4 plus or minus 1/4 I square root of 7. And then don't forget, we have our other zeros here, which are plus or minus 1. So that's going to be plus or minus 1. Whew. All right, we got 2 more questions here, and then I'll get to the halfway point for you guys, and I'll take a little break for those of you that have joined into the chat. All right, so for the next one is writing the following equation given the zeros and multiplicity. Hopefully you guys are enjoying this lovely homework assignment. All right, so again, just remember, guys, that when we're given our zeros, zeros come from, let me just do a quick little example because I think this really drives it home. In Algebra 1, we learned how to solve an equation, x squared minus, x minus 2. And to solve the equation, solve the roots, find the solutions, we set equal to 0, and then we got x minus 2 times x plus 1. And then we did the zero product property, x minus 2 is equal to 0. x plus 1 is equal to 0, and then we solve. X is equal to 2, and x is equal to negative 1. Okay? So the important thing is I'm giving you the zeros, and I'm asking you to write the equation. But to go from zeros to the equation, we got to find the factors. And the main important thing is I can set each of these equal to x, 2i, x equals negative 2i. And I've already done this in the other homework examples. Right? So now to set them equal to 0, okay, you're basically just, subtracting a 2i, adding a 2i, subtracting a 1/2, adding 1/2. And then those are basically going to be your factors that you're going to multiply. Now, the nice thing about this here is understanding your special products. Because in this case, I get x minus 2i times x plus 2i. We'll want to make sure we write this, instead of subtracting the 2i, I said that wrong. You should multiply by 2 and subtract 1. Multiply by 2, add 1. So therefore I have a 2x minus 1 and a 2x plus 1. Okay? And so what I notice here is this follows the same relationship of a minus b times a plus b. And you guys remember that when you multiply in that form, that creates a difference of 2 squares. So that was kind of like the point that I wanted to come across with these first problems, is recognizing, the difference of 2 squares, recognizing that you can factor this down using difference of 2 squares. It doesn't matter if it's rational numbers, doesn't matter if it's imaginary numbers, or I guess I just didn't do any irrational, or just irrational numbers as well. But look for that relationship of the difference of 2 squares. So I'm just going to multiply these by squaring the first term, squaring the last term, and then subtracting those 2 terms. And what I get here is x times x is x squared. Here I get 2i times 2i is a 4i squared. I squared is negative 1, so that's a negative 4i. And then obviously you're subtracting them though, so you get an x squared plus 4. And again, if you're unsure about that, you can always check your work here, guys. Just take x squared. Let's do it down here. Take x squared plus 4 and set it equal to 0. You get x squared equals negative 4, square root, x equals plus or minus 2i. Those are your zeros, and that's how I got to the factor, right? So we got that one covered, and then this one is going to be 4x squared and then minus 1. All right, and now we just have a difference. Now we just need to multiply these, and so we'd have a 4x to the 4th. Sorry about that. Let's see, plus 16x squared. Oh, now I'm losing my mind. 4x squared. Why am I doing it that way? I don't know. Minus x squared, and then minus 4. So now my final answer is 4x to the 4th. 16x squared minus x squared is going to be a positive 15x squared minus 4. All right, last one, and then I'll go ahead and take a break for you guys. So now I have the grouping 3, 1 minus I squared of 2. Again, if we were going to set this 0 here, is x equals 1 minus I square root of 2. And again, if I wanted to set this equal to 0 to find the factor, I would just subtract a 1. So x minus 1 equals negative I square root of 2. And then I would add the I square root of 2. And therefore I'd get x minus 1 minus or plus I square root of 2, which is exactly the same process that I did over here. Now again, though, remember, if 1 minus I squared root of 2 exists, then we know that the conjugate pair also has to be a 0. So rather than doing this whole work again, I just know that my other factor is going to be the same factor, just with the negative I. So my linear factorization here, I'm just going to write this as a factor, which would be x minus 3. And then I'm going to have x minus 1 plus I square root of 2 times x minus 1 minus I square root of 2. So I showed my students a couple different ways to do this. I prefer in this method just to kind of use this little shortcut, which is again recognizing the difference of 2 squares. So again, you can see here my 2 terms are the same. My last 2 terms are the same. So again, I can just multiply this using difference of two squares. So therefore, I get x minus 3. Here, I'm going to have x minus 1 times x minus 1 is x minus squared. Here, I'm going to have a negative I times a negative I is a negative I squared. Well, I squared is negative 1, so that's going to be a positive 1. So that's going to give me, and then square root of 2 times square root of 2 is going to be 2, so that would be a plus 2. Okay, now I can expand the x squared minus 1, and that's just x minus 1 times x minus 1, so I'm left with x minus 3 times x squared plus, minus 2x plus 1 plus 2. And then obviously, guys, you can see that 2 plus 1 is going to be equal to, let's just do the next one. Let's just do the next row. I got a row, right? Yes, perfect. So x minus 3 times x squared minus 2x plus 3. Okay, and now if I was going to multiply this, I'm just going to use the distributive property here. So this would be x cubed minus 2x squared plus 3x. I'm multiplying the x times every single term. And then I'm going to multiply the negative 3. So this would be a negative 3x squared. Negative 3 times 2 is going to be a positive 6x. And negative 3 times positive 3 is going to be a negative 9. And then I'll just combine like terms here. I get an x cubed. These combine to a negative 5x squared. This becomes a positive 9x minus 9. Whew. All right, I'm going to go and take a little break. Check in with you guys. Please, slow, steady, all in one available. Hi, sir. I'm from India. Well, awesome. So cool that you could join here from India. Let's see. Mukhtar says, thanks, teacher. I really get profit. Awesome. I'm happy my video can be able to help you guys out. Hop says, hello. Hey, folks. Even though major involves a lot of math. So Zach has a question. I do use math a lot, but now I'm taking useless biology in classes. I spend only a little time in math, even though my major involves lots of math. Well, hey, man, just, the thing is, there's nobody that's restricting you to how much math you can take. That's the cool thing about YouTube or online learning. Like, there's so many other great teachers out there that are teaching so many other courses available on math that you guys can learn. You can learn math from anything, from anywhere. So that's a really cool thing. I would just say keep on learning math. Don't be restricted by, where you're going to school or, what you're learning and stuff like that. Yusuf says, thank you. Yusuf, you're very welcome. Happy to be able to help. Allie says you're a great teacher. Well, thank you very much, Allie. I'm happy to be able to be here for you. And hey, Freshie, where are you from Florida? Let me know. I am up in Jacksonville, and I'm originally from Michigan, but I have lived in Jacksonville here for probably like 11 years now, and I'm starting to get used to the warmth. But I think like this last month in September, it's been so hot, like for so long. I'm like really sick of being the warm weather. I'm really looking forward to getting some cooler weather, getting that fall, at least Florida fall, as we come sometimes kind of joke around, because it's nothing compared to other parts of the country or the world for the fall. But all right, guys. Well, sweet, Jacksonville. What's up, man? My neighbor. So what we'll do here is we will finish up this multiple choice. And then let you guys know also, I did end up doing a live stream, or ended up putting a quiz that I'm going to give my students. So I will plan on, let's see here, I'm going to give that quiz on tomorrow and Monday. So I'll be going live on Monday, and then all of next week I will not be going live. But Monday will be my live stream for the quiz, and then we'll be back next week kind of in town. So, all right, this live stream is taking way too long. I'm almost like getting up to 45 minutes on this, I think. Jeez. I don't know. It's not showing. Oh, yeah, 33 minutes. All right. So let's go and knock this out. Knock this out so you guys can get back to your regular duty. And we'll move on. And I can get home and pick up kids and do all the other fun stuff I get to do. All right. So it says use Descartes' rule of signs to determine the possible number of positive and negative real zeros. So remember, the number of positive real zeros is just the sign change of our f of x. So we see 1 sign change, 2 sign changes, and 3 sign changes. And then remember, it's the number of sign changes minus an even number. So the only even number I can subtract from 3 would be 2, and 3 minus 2 is 1. So therefore, it could be A, it could be C, but it can't be B, and it can't be D. To find the number of possible negative sign changes, I have to evaluate for f of negative x. So that would be negative 4 times negative x raised to the 9th power, plus negative x raised to the 7th power, minus negative x squared plus 6. And just remember, guys, any negative number raised to an odd power is going to remain negative. So that remains negative times a negative is now positive. So 4x to the 9th. Negative 7, that remains negative. So negative x to the 7th. And that turns into a positive, but positive times a negative is going to still be negative. And then plus 6. And what you can see here, there we go, is how many sign changes are we dealing with here? We're dealing with 1, 2. And so it's either 2 or minus an even number, which would be 0. So you can see that my answer here is going to be A. The next one says, given a degree of 4 and zeros, 2i, 3, and negative 3 are zeros, find the leading coefficient. So again, remember, if x equals 2i is a 0, then x equals negative 2i is also a 0. Okay, and I'm going to get into writing the factors really quickly here. I'm just going to say the factors then are negative 2i and x plus 2i. For 3 and negative 3 is going to be, x squared minus 3, oops, not x squared, x minus 3 and x plus 3. Shoot. Okay, and then so if I was going to multiply this out, again, guys, it's a difference of 2 squares. Like, recognize the difference of 2 squares. You don't need to do the box method or distributive property. This is going to be x squared plus 4, right? And then if I can multiply this down, again, using difference of 2 squares, this is going to be x squared minus 9. Now, if I multiply these out, I notice here I'm going to get x to the 4th. This would be a negative 9x squared, positive 4x squared, so that's going to be negative 5x squared, and then minus 36. And searching, I see that C is the answer. The next one is find the nth degree polynomial with the collider coefficients of negative 2 and 3. So again, we got to do that. If negative 3 plus 2i, guys, is a 0, then that means negative 3 minus 2i is a 0, right? So these are your 2 zeros with negative 2. So let's write these as factors, and we're going to do that same step that I did before. Negative 3 plus 2i. Well, what the heck am I doing? Let's write these as factors. So the factors would be x plus 3 minus 2i, and then x plus 3 plus 2i. Okay, recognizing the difference of 2 squares, I now have x plus 3 squared, and therefore this is going to be I squared, which is a negative 1, and then negative 2 times 2, which is a negative 4, so that's going to be a plus 4. I can expand x plus 3 squared to give me x squared plus 6x plus 9, and then plus 4. So that gives me a x squared plus 6x plus 13. And then remember, we need to multiply it by this other 0. So if x equals negative 2 is the 0, then we need to multiply it by x plus 2. Now, before I multiply all this, you can see that my last term is going to be 26, so that cancels that one out. My first term is going to be x cubed. That's good. So it looks like they want us to multiply everything out. Great. So x times x is x cubed. X times this is positive 6x squared. X times this is going to be a positive 13x. 2 times x squared is a 2x squared. That's going to give me 8, so it's not going to be that one. And let's see, 2 times x squared, 2 times 6x is going to be a positive 12x. And let's see, if I was going to combine these, that's going to be 25. And you can see here, there's my answer D. Okay, so obviously if you add the last one to give you 26, you're good. The next one says list the possible, and we're almost done. List the possible rational zeros of the polynomial function. Do not find the zeros. So again, remember when we're doing the rational zero test, we're basically looking for the factors of p over the factors of q plus or minus. And p is the constant of the function, and q represents the leading coefficient of the function. So basically what we're looking for is plus or minus the factors of p over plus or minus the factors of 6. So that's p over q. And it's really plus or minus for each factor. Now, typically when I do this, I just like to write the plus or minus in front and then do everything on top. So now I'm just going to list the factors of p, which are 2 and 1, and the factors of 6, which are 6, 3, 2, and 1. And now basically, guys, what we're doing is we're just going to connect all of these and then we can simplify. So we can have, so plus or minus, it's basically 2 over 6, 2 over 3, 2 over 2, 2 over 1. Now, you guys can see that these simplify out, right? So you can see this simplifies to 1/3. This simplifies to 1. You know, that simplifies to 2, right? And so on and so forth. So now I'm not going to repeat them. So now as I go over with my 1, I'm not going to repeat any of them. So I have 1 over 6. But I have 1 over 3, but I already have 1 over 3, so I'm not going to repeat it. 1 over 2, I don't have that. That's a new one. And then I have 1 over 1. But did I not do 2 over 2? Oh, I missed that. So I did. No, I did. I already have 1, so we're good. Okay, so now I just got to be able to see which one is going to have all of these. And typically you can see here the 1/2, the 1/3, 1, 2, 3. Good. And 3 is not 1, so it's not this one. This one doesn't have the 1/6, so that doesn't work. This one has the 1/6, the 1/3, the 1/2, 2/3, and the 1 and the 2. So how are these different? So this one doesn't have the 2/3, but we know the 2/3 there. So therefore the answer is B. All right, last one is for the polynomial, 1 0 is given, find the others. All right, so if we're given the 0, which is 1, and now we can just go ahead and set up synthetic division. So we'll have 1, -3, 7, -5, right? So bring down the 1. 1 times 1 is 1. -3 plus 1 is -2. -2 times 1 is -2. 7 plus -2 is 5. 5 times 1 is 5, and 0. So you better get 0, otherwise you did something wrong, right? Or otherwise it's not a 0. So that's a remainder, constant, linear, quadratic. Now, again, remember, guys, if this divides into this evenly, that means x squared minus 2x plus 5 is a factor. That means now I can solve this. But I see that this is non-factorable, so therefore I'm going to set up the quadratic formula. I'm not going to I'll work this here a little bit quicker. So -2 squared is 4 minus 4 times a times c. So that would be times 5. And I'll divide it by 2. 2 times 1. So in this case here, we're going to have -16. So that's going to be 2 plus or minus. The square root of -16 is going to be 4i over 2. And then they divide that 2. So x would equal 1 plus or minus 2i. And is that one of the answers? Yep, there you go. 1 plus or minus 2i. And sorry, guys, I did do that a little bit quicker, you know, for those of you checking in. So, hey, guys, Charles, Faz, Tyler, Charles back, Hussein, awesome. Glad to have you guys back in on the chat. Cool, Charles, sounds like great. Jared's here, awesome. So, all right, guys, I am going to wrap this one up. It kind of took me a little bit longer, 43 minutes than I usually like to do for my live stream. But either way, just to remind you guys, I'll be back next on Monday. We'll cover the second quiz that I gave my students. That's going to cover, again, more irrational as well as rational zeros. So I'll go ahead and cover that. And then, obviously, if you guys have some questions that you want to get answered, you know, make sure you can reach out to me. I am trying to remember, and I'm really bad at this, but I'm trying to remember to make sure that people know as far as on my either Patreon account or the membership in YouTube to letting you know when I'm going live, so therefore you can kind of submit questions and answers. But obviously, guys, that doesn't mean that you can't submit questions here while we're going live, and I'll be able to answer, you know, happy gals out as much as possible. So Magnus, hey, how are you doing? Luis, how are you doing? Sorry, guys, I'm just finishing up, but hopefully you guys did get some value, or at least you guys can go back through this. And again, if you guys do want copies of this, just let you know that is one of the things that I'm working on is, using that Patreon to really kind of allow myself to continue making these and then also to provide them. So that is one of the things I do provide, is at least these copies. So for those of you that really are going through the pre-calculus curriculum and like kind of these worksheets and like to see my answers and would like some copies, just reach out to me. You can definitely check out the Patreon page, see if it's something that's right for you. If not, totally cool. I'm going to still be making videos and doing these live streams for the rest of the year. But if it's something that you like to have printed out or like a copy of, or you want to do it yourself, that's why I kind of created that Patreon. And really, it's not just to, it's really that's not for money for this. It's really so I can start investing in, having these recreated, having these edited, having the answers provided in a written out, typed out form, all the things that I got to pay for, which kind of stinks. But either way, guys, appreciate you guys joining the stream here. And hey, Charles. So appreciate you guys joining the stream. And I will be back on next Monday. All right. All right. Peace.